Okay, so hey guys, welcome back. Just give me a minute. Actually, I am setting up something. Sorry for the interruption. Yep. Okay, so let's start. Okay. Yep. All right. So here we go. The welcome back to our channel, guys. Welcome back to our channel, guys. This is Ashang David, and welcome to our DSA live stream. And in today's class, we will be continuing our linked list concept. As you can see on the screen right here, this is the place where we left in the yesterday's class, in the last class that was on Saturday, and we are going to continue from that class into this class. Let us start without any further ado. Before I start with this live session, I want you guys to please do share this live stream to those people who are learning DSA or they are about to start learning the linked list concept or DSA, so that they can also learn it. This is totally free and this is for placement. So we are going to learn only specifically to your placements, solving questions which are asked in the companies, and only we are gonna do that related to placements only, everything in this live session. This is Ashang David. Let us start this live stream, and there you go. So in this live stream, what we are going to cover today? Today we are going to cover the linked list concept, and the linked list concept till where we have done in the last session. I have told you the very first method of creating the linked list, and that was using call by value, call by reference. The differences I have explained. I told you about call by reference part, call by reference way of doing it. Then I told you double pointers way. I have told you this also. So this is what we have done. In today's class, we will be talking about the other way, the second type of way. As I have told you that we are doing it without creating classes also and with creating classes also. Two things I have told. So today we will be seeing the easier method, that is with creating class. So guys, when you create a class, it becomes much more easier because you don't have to worry about the creation of the head later on in the main. What I am trying to say is, you see, one more thing, we are coming live, as you have told us that we should come live for C++ object oriented also. So I have come live today only at 4 p.m. So if you have missed that live session, please go ahead and watch in our YouTube channel. I have created a playlist, Mastering C++ Object Oriented Programming Concept. So if you are really interested in learning C++ Object Oriented, today I have recorded and I have put it up the first video also. The first live session I have also recorded it. So if you want to attend, you can attend the class at 4 o'clock sharp in the evening, Coders Arcade Live, and we are teaching there object oriented programming. If you are missing that, you can later on go ahead into our playlist and see that for yourself. Alright, so now let us continue, guys, and I hope so that you guys are fine. Everything is fine in this stream right now, nothing is wrong here. Let us continue, guys. So in this case, we have come across till this part of the code, and I have explained you about how we are creating the node class. In this case, the node class is gonna be the same. In this case, there is no change into it. And also, if I open up my Microsoft whiteboard, then I have explained this as well. I'll open up what I have done it in the previous live session. Just a minute, guys. All right, here you go. So here you see I have shown you that this is how your linked list would look like, and this is the node system, and this is the head pointer pointing towards the first node, and each and every node is connected to each other, while this is the data, this is the next pointer. Well, like this is the data, next pointer, data, next pointer, data, next pointer. It is pointing towards in one direction because it has only two partitions. There is one data and next. So next pointer is pointing towards the next particular node itself. Right? We have understood this. This is how it is done. What are the operations we had to perform? We are performing insertion at the head, tail and position, and deletion also at the same place we can do. Then we are performing the traversal also, and the implementation I started to explain on the last class. So how implementation is done? The first step is to create the node, and then you have to connect the node to each other to form a particular type of a list, and that is what your linked list is in this case. So in this case, the implementation part is this. So this is how your linked list looks like. But how would you create the first node? To create the first node, you had the node class itself. So if you see here, I have created the node class itself. So class node. If you are not able to understand what is this, don't worry, don't have to panic. Anyways, this class, this live session will be also recorded and will be kept into our DSA placement live playlist. So if you don't understand right now, I will be recording everything from today's class, and I will be, this whole live session will be recorded and kept into that playlist. You can first go ahead and watch our the very first one, the beginning class for our C++ mastering C++ object oriented concept. There I have explained you what are classes, what are objects, what is methods, what are attributes, everything I have explained. In tomorrow's class, in fact, I will be doing the constructors part. So don't miss that class. Okay, tomorrow's 4 p.m. class. Anyways, well, I have created the class node here, and in this node class, in the public section, I have even explained what is this public, what is this node class, everything is there in the mastering C++ object oriented playlist. So if you have missed that, please go ahead and watch that. Again and again I am saying that. Alright, let's continue. So here this is the node class which we have created, and in the node class, if you see, in the public section I have taken two variables, and that is int data and node star next. Int data specifies the first half of the node, and the node star next represents the next part of the node. As you can see in the diagram here, you see that in the node, in any node, if we zoom in, you can see that it is partitioned into two parts. One is the data part and another is the next pointer part. While next pointer was storing the address of the next coming node, and this is how that node and this node was getting connected to each other. I hope so that this is very much clear. So that is the reason why I have taken the two attributes of this class node, and then later on I have created the constructor. Tomorrow I am going to explain you what exactly is a constructor in our mastering C++ class. So please do not miss that. Again, this is the constructor, and because we have a attribute here, we are creating the constructor, and here in the constructor, because what is the constructor? Constructor is a function which has the same name as the class name. Its job is to initialize the attributes which are these to the class back there. So in this case, we have created the constructor, and with the help of the constructor I am initializing the data, as you can see here. Okay, and so this dot data equals to data, and because we are not knowing what is going to be the next value here, so I have taken this of next is equals to null. Why null? Because it is a wild pointer and we don't require wild pointer in our program. We should avoid having wild pointer in our program. So that's the reason why we have done it. I hope so that this is very much clear. I hope so that this is very much clear. Now next up, our node class got over. So we have a blueprint ready for our nodes to be created. Now of course, in this case we have started with our insertion function, where the very first insertion that we are doing here is gonna be on insert at head. So let us see what we have done here. What we have done, we have said void insert at head, and inside that I have taken two parameters, the value and the head pointer. Now in why we are taking these two parameters? Because of course if you are calling a function insert at head, if you are asking someone that you have to take this value and go to that head and insert it, that person should know what is the value, so I am passing the value as a parameter to that, and also where is this head present in the linked list. Understood? Because if we don't know the head, how will this function will go to the head and do the insertion? Am I correct? For that reason we are passing two parameters here, that is value and head. Now what is this double star which I am writing? See, head is a pointer, right? Head is what? A pointer. Now because there was no pointer in this program, the head pointer had to be created into the main function, and as soon as I have created the head pointer in the main function, I have initialized it to null because there was no linked list present, right? So basically head was a pointer in itself, and I have taught that when you call a function, see what I am doing is I'm creating the head first, making it to null, which tells us that the linked list is empty right now. Then I am calling the inserted head and calling this function, and then adding the element at the head with the help of insert at head. Alright. So in this case, when I call this, you see that one more thing. Now I have explained this to you, that this is what? This is a void type of function, and when we call a void type of function, we generally pass the reference of the variables rather than passing just the value. In the case of val, we just directly pass the value. So because it is just a empty variable which is now accepting the value, the number, the data, but in this case head was already initialized before here in the main, so which is in a different scope. So we need to provide the reference of that rather than passing the whole head as it is. We are going to provide the reference. Here we are trying to do call by reference rather than call by value, and that is the reason why I have written ampersand of head rather than just head. Understood? I hope so that this is very much clear. Now because head was already in itself as a pointer, and to pass the reference of the pointer we need a double pointer, and for that reason we have taken double star. Now if we go back to our session 2 or 3, there I have explained you what exactly is a double pointer and how it works. So all your doubts will be cleared at that point, but if you have any doubts in the running time, only I will be explaining all your doubts and I will be clearing, because the screen is right over there. I can see all your comments and chat, so please you can ask me the doubts as you want to ask. I hope so that this is very much clear. Now coming up next is gonna be our logic of the insert at head. So what is the logic here which we have written? We started by creating, we have understood this in our whiteboard, that in a blackboard, that if I want to insert, do an insertion, these were the 3 steps. First create the node, so I have created the node, then connect the nodes n of next is equals to this. How do we know the address? This, the head was already pointing there, so I have taken that from the head. Understood? First of all, creating the node. How did we create the node? To create the node, I have said node star n is equals to new node. This I have already explained you already. What exactly is this? This is the pointer of the node, and we are dynamically allocating the memory using new keyword, and we are doing this, calling the constructor explicitly. I hope so that this is very much clear. So this is the creation of the node. This was the step 1. Now the next step was to connect the first node, which is created node, to the already created first node in this case, which is this right now. So to connect this, I need this address, and where is this address being stored? This address being stored inside the head. I don't know the address physically, but I know this, that head is storing that value, right? So I took that value from the head. So n of head equals to n of next. N of next is equals to head, which means through which we are doing this. I hope so that this is very much clear. So this is how it got connected. Alright. Well, next up, in this case, when I go back to our program, you see that here we have the node star n is equals to new node. I have created the node, and then what we have done, we have taken the value of the next upcoming node from the head itself in this case. Alright. So here n of next is equals to head, and because head is already a double pointer, so we have taken the single pointer, single star, to dereference it once so that we can use it. I hope so that you are getting it. Call by reference we are doing in this case, and then at last the head pointer should point towards The head pointers, rather than pointing like this, should point towards that node. I hope so that this is very much clear. So for that reason, what I have done is head pointing towards N. Clear? Very, very, very much clear. I hope so that this is very much clear. Next, this was one way, guys. I hope so this is very much clear. Now, that one way was creating the node class separately, and then we are not creating any other class, we are just directly writing the function, okay, and then directly creating our head into our main. This was the way that I have taken. This is the second way, okay, this is the second way, and I bet that you will like the second way more actually. Let me just close this off. Now, the second way is, after creating the node class, you can see after creating the node class, rather than creating the node class, after creating the node class, rather than directly writing the inserted head function outside any other class in the global scope, we are writing that inside a linked list class. So I have created the linked list class linked list, and the attribute of the linked list I have taken it as directly in the public section of the class linked list. I am directly initializing node star head here once. Directly I am saying node star head is equals to null. So not is equals to null right now, but I will say that very soon. In this case, after doing this, what I will do is I will create a constructor of the class. Let's say it is gonna be linked list, and it is gonna be a default constructor because I don't know any other value of the head in this case. So what I'll do is I am going to just directly create it like this, and then what I'll do is I'll not write any parameter actually. So in this case, what happens is that I'll just directly say head is equals to null. Okay. With this, what will happen is that the default constructor will be used to initialize the head to null. I hope so this is very, very much clear. Okay. Next up, the benefit of creating this linked list class is that now you can directly write the insert at head function here only. So void insert at head directly here only, okay, and you just have to pass the value, that is int value. You don't have to even pass the head. Why? Because now you see here, guys, you don't have to pass the head pointer like this. Here you had to pass the head pointer with a double pointer, right? But in this case, now you don't have to pass any head. Why? Because head is already present in the same linked list class where this function is kept. I hope so that this is very, very much clear, right? In this case, you have to get the reference of the head because the head was in another scope only itself. It was in another scope itself. So there was no connection to that head. Are you getting my point, what I am trying to say? So what we did is, in this case, we made the head available in the same class itself. So that is the main reason of creating a separate class called as linked list here. Class node and a linked list class. This is a far much more better and easy way of doing this. What happens when I make a class like linked list like this? When I create the head pointer directly right here, I don't have to pass the head. And when I don't pass the head, it is already available in this case. So I don't have to worry about call by reference, double pointer, call by value, nothing like that I have to worry about, and it will work as smooth as a butter. Understood? So in this case, this is how we will create. Okay, logic will be the same. First, start by creating the node. How do we create the node? We say node star n is equals to new node, explicitly calling this and passing the val. And this is the step 1 done. I hope so that this is very, very much clear. Okay. Now it says that the node constructor is inaccessible. Why? Because there is no public written anywhere. So I'm going to create public right here. Okay. and now this will be able to, we will be able to solve this issue. Okay, I hope so this is very much clear. Next up, after creating the node, after the creation of the node, what we will do is we will point the newly created nodes next, which is null right now, to the already existing node. This is what I have done. No, here what I have done is that I am saying that this n of next which was null in the beginning have to take up this value, correct? Yes. So how do we do that? This value I don't know this value, but who knows this value? The head knows the value. So what I did is I took it from the head, and what happened is that value came right here. So to do that, what I will do, I will say n of next is equals to directly head. One more thing, now I am not using any head pointer here. Why? Because head is not a double pointer, so I don't have to write any star, and my head is already present here, which is null right now, so I don't have to worry about anything. I can just directly say head. This is far more easier, and I will be using this way. If I use the another way, it will become too much difficult for some people who don't know about call by reference, so I will not pick up that way, but I will pick up this way. This is far more easier to understand as well. Okay, so now next, at last, what I will do, I will say head, you also point towards the value and the newly created node. So what happens is that this is our inserted head function. I hope so that this is very much clear to all of you guys. Okay, now if you have any doubts, please ask me. So this is our inserted head, finished in both the ways, with creating classes and without creating classes. Alright, next up, so we are gonna do what? So this was our node, okay, and I have done the insertion at the head. Okay, now what we will do is I'm gonna cut out this linked list from here, and I'll paste it in a new workboard so that I can use this. I'll copy this up, okay, and I will, 1 minute guys, I'll open up this Microsoft whiteboard, create a new whiteboard, make it as a black, and I will paste that right here. Absolutely fine. Okay, so this is our linked list which we have taken out. Now we will try to do the insertion at the tail as well. Okay, so now we are going to try to do the insertion at the tail also. Okay, how to do it? So guys, this is your linked list. So guys, this is your linked list. Now you have understood the inserted head. which is very, very much fine. So our, I can say here, insert at head is done, over. Next up is gonna be insert at tail. Insert at tail. We will do position at the last, but I want to do insert at tail first. So that is the tail, as you can see, that is the tail, and we need to do with the insertion at the tail. Oh, one thing before I go ahead into insert at tail, let us just try to print this, because we have not cross checked our answer. Print the linked list. We have not done printing part. We have done inserted head, but we have not done printing part. So let us try to print the linked list. Let's see. Now you guys tell me, if I want to print this linked list, how I would do it? How will I do it? It is not as that easy as an array, because I can, in the array I can just put a for loop, I can just iterate it, and then I can print the elements. But very similar to that actually. Here also I am going to do the iteration. But in this iteration I am not going to use a for loop. I will not use a for loop. Why? Because we don't know exactly how many number of nodes are present into our linked list. Got my point? We don't know about it. So we cannot say anything into this matter. So I will not use a for loop, rather I will use a while loop. And when I use a while loop, I need a condition. For a condition I need a variable. And can you tell me what variable or iterator I can use here? Yes, you are correct. I can use what? I can use the temp variable. Yes, I can say temp. I can say temp. You start from the head, correct? Temp, you start from the head. Do one thing. You are standing right there on that first node, print it. Print it. How you will print it? You will say cout. Cout. You see, temp will be a temporary pointer which will be pointing towards the head. And if it is pointing towards the whole head, which means it is pointing towards this memory, it will be able to access the data. So I can say here temp of data. Cout temp of data I can say. Understood? I can say this. Temp, you are standing at the head. First print the head data. So temp is equals to cout is equals to temp of data. So cout temp of data you printed. Where the temp is actually standing, which is the head node, which is the first node, print that node. And then I will say temp, you do one thing. You jump to the next node. But how it will jump to the next node? You see, first the temp was standing there and temp was holding this 2117, right? 2117 was held by the temp. That means it was right here standing. Now I want 2187 to be stored in the temp. And where do we have that? We have it right here. So if temp accesses its own next, it will be able to jump to the next node. Think about it, guys. Temp is standing here, and in the node, the next pointer is holding the next node's address. So if I ask temp, you access your own next, which means I am trying to do something like this. I am trying to do something like this. Temp is equals to temp, you only access your own next. Temp is equals to temp of next. And when this happens, the temp starts jumping to the next node. Clear? Easy? Temp, you are standing at the head, print your own data. So see out temp of data. Then temp, you access your own next, and when you access your own next, you will be able to jump to the next node. So temp came here right now. Temp came right here, and when temp came right here, see out temp of data, and then temp is equals to temp of next. Clear? So temp reached here. Now temp is standing here. So I said temp, you access your own data and print it. So print see out temp of data. Okay. And then I said temp, you access your own next, temp is equals to temp of next, which means now you jump here. So temp came here, started pointing towards this node in this case, and what happens? That the temp accesses the data and prints it, and then you access its own next, jump here again, access its own next, print it, and then access its own next. Now guys, in the last scenario, you don't want it to access this last next. Why? Because it can go out of bounds. You don't want this thing to happen. You don't want this last next to be accessed, because if it goes there, what happens is that that will go out towards null. Understood my point? We just need to access its temp of next, that is till there, not after that, because as soon as that will get over, the loop will be executed one more time. In that case, it will go out of bounds. We don't want that to happen. Understood? So for that, to save that, what I will write? I can say, let us write it together, Let us write it together. Let us write. So first, I'll say, so let us write the signature in this case. So this is gonna be insert at tail. Okay, insert at tail, and I want to do this. So I'm gonna take the value at least you will take. I will create the one more thing, the condition has to be checked. No, the condition has to be checked, because if the head is equals to null, in that case the linked list doesn't exist, and if the linked list doesn't exist, that means there is no tail, and if there is no tail, there is no point of doing anything. In that case, you can just say return nothing. Do nothing, you just come out of the function. Or why it should fail? Why it should not do anything? It should do anything. If there is no head tail, then do the inserted head only, no? So just before we have written inserted head, so we can call that function here, insert at head. Clear? I can call this inserted head function, right? And I can pass the value right here. So now what happens is, if the head is equals to null, rather than going and searching for the tail, it will do the insertion at the head only, and it will get over. Easy? Understood? Or let us say you have not written insert at head. If you have not written insert at head, then your new node itself will become the head itself. So I can say head, you start pointing towards that end. Understood? But for all these things to happen, we first need to create the node. Node star n is equals to new node, and pass the val. So this way, what happens is that first the node is created n, and then I said that if the head is equals to null, that means there is no tail. In that case, the head pointer, which is null right now, will start pointing towards the end. So end's value will be updated to the head. Alright, I hope so that this is very much clear to all of you. This is our condition. Now, chalo, this is for the condition so this is the condition for if the head is equals to null, correct? But what if the head is not equals to null? When the head is not equals to null, then in that case our normal program will run, correct? So in this case what happens is that our temp variable we need to create. So I'll say node star temp start is equals to null. This is gonna be equals to null. Okay. Node star temp is equals to null. And we have done that already. Here, as you see here, node star temp is equals to head actually. This has to be head actually. Okay, this has to be head in this case. So this is like node star temp will start from the head, and when this will start from the head, what happens? It will point here. So now I can write the condition for the while loop. In this case, as I told you, we will use the while loop. So I'll say after this while, what will be the condition? I need my temp just reaches null, that's it. Temp of next doesn't reach null, but I want temp to reach null. So in this case what I'll say? Till temp is not equals to null. Temp is not equals to null. Till there only. Till temp is not equals to null. First what you need to do, because our head is our temp is at position head, so I need to print it out. So cout temp of data. Understood? This is very well understood. Now I will say temp, you go to the next node by accessing your own next. Temp is equals to temp of next. Clear? Bus, this is done. So it will keep on doing this until and unless it reaches at the last, and this is gonna be a logic for insert add tail. I hope so that this is very much clear to everyone. Okay. Acha, one thing, that this is not insert at tail. This is what? This is the printing part, right? So I can just directly write, rather than writing this, what we can do is, this was done already and we don't want to insert in this case. This was just a traversal function and I don't want to insert in this case. I confused it with the insert at tail. So I don't want this in this case. So what I am doing is, I am just writing I don't even want this as well. Wait. I wanted to do insert at tail in this case. not insert a tail, but to print just. So if I want to do this, then what I will do, I can just say here, wait, yeah, the thing is that I just want to print it. So in that case, what I'll do is, this logic is correct, but I don't want so much of it. I'll just take it a little bit upwards. Okay, somewhere here. So in this case, I started temp till temp reaches null, and then I'll directly say print the data and go to the next one. Okay, this is gonna be your void display function. Okay, this is gonna be your void display function. I hope so that this is very much clear to all of you. Up next, let us write the code for it then. This is my inserted head done. So what I'll do is, now next void display, and if I want to do this void display, what I need to do, first start by creating the temp equals to, this is going to start from the head, node star temp is equals to head, while temp is not equals to null. Just till then, first of all cout temp of data, and then temp you access your own next. Alright, like this. I hope so that this is very much clear. So this is going to be our display function for linked list in this case. Now I want to do some execution part. So if I want to do execution part, what I'll do is, I will say first I'll start by creating the because I want to call this function insert at tail. Insert at tail function is kept inside the linked list class. So what I'll do is, I'll create the object of the linked list class first. So I'll say linked list ll as an object, and I will say ll dot insert at head. Now one more thing, did you see here guys, when I said ll dot, you see display function is coming, head function is coming, and insert at head function is coming. Now I want only display function and I need the inserted head function, but I don't want this head to be exposed, because anybody can change it manually or accidental changes can happen. So for that I'll do one thing, I'll move this public down so that only the constructor is, not even constructor I require actually, I only make the inserted head only public in this case. I hope so that this is very much clear, but it is still is not okay. So what I'll do is, I'll just make this public right above the constructor in this case. So what happens is, now that the head will not be shown anywhere, dot, see only display and the inserted head function. Alright, anyways, we got this. So first I will do one insertion. So ll dot inserted head, I will pass the value, let's say 10. Do the insertion at head as 10. Okay, understood? And then display it. So now I will run this code and check if the code works or not. And you see that 10 is being printed already here. 10 is printed here. Can you see this 10 being printed here? Yes. So this means that our inserted head is working fine. But I also want to check more that if it is working fine for more insertions or not. So I will check insert at head, and I will say, let's say insert 20 at the head of 10. That means now the linked list will look like 20 and then 10. So when I run this code, it should say 20 and then 10, right? Looks good. The thing is that everything is, clumsy here, where there is no space or nothing in this case. So what I'll do is, I will go into the display function, and here after just doing this, cout temp of data, I can print one space here like this, and you see that it prints some nice space in here, as you can see, but it still doesn't looks good. So what I'll do is I'll just keep a arrow here, and when I'll keep an arrow here, you see what happens is that I run it, prints like this every time. Now it looks far more better actually in this case, but then this extra arrow is not looking nice. So what to do for it? I have an idea. After doing all these things, after printing each and everything, come out of the while loop and then you print null in big capital letters. That means we have reached the end of the linked list. So, and after that you go to the next line, so it is ready for more inputs. Okay, now this is much better. So now when I run this code, it somewhat looks like this, which is a much more better output to see and look at, right? So this is how your inserted head function is absolutely working fine. There is no issue into this, and yep, you can test it for on your own if you want. We can just do some more insertions like this. I can just keep on saying copy, paste, and I said this is 20, this is 30, this is 40, 50, and this is 60 in this case. Okay, and now I'll say run. As we can say how beautiful our linked list is looking like. This is your insert and head. Understood this really well? Any doubts? You can ask me in the comment section. There are no doubts in the comment section. So this is your display function, and in today's class we have discussed about insert at head in a different style. This is much more easier style. It takes up less less number of concepts to be involved, like while pointers, double pointers, call by value, call by reference. This way is far more easier than doing what we were doing in the last time. Okay, one more thing before we leave for today. In the previous program where I was using double star, to avoid double star, if you don't like double star in this way, you can reduce one star from here and you can put an ampersand right here. Okay, when you put an ampersand right here, then you don't have to put the ampersand in the call in this case, and when you do this, everything is fine. Just remove these stars also from the usage inside their bodies. What happens now is that same thing is happening, but what is happening here is that rather than passing all the time reference of the head manually, I made the parameter only a reference variable. This I have already explained into my pointers and variables concept. So if you haven't watched that, please go ahead and watch that video first. I have explained about this into our session 2 of the DSA prerequisite, which I have already done in this playlist. Same playlist you will find it, and I have done a separate extra video on pointers, variables, reference variables, where I have all explained about each and everything in depth. So if you don't know about it, please go ahead and watch that. You can just search for a pointers YouTube video for Coders Arcade like that, and you'll get it, where I have explained it to you very well there. I hope so that this is very much clear to all of you. Well, that is it for today, guys. Any doubts, you can please post them into the chat and I'll be able to see and solve it if it is in my power. Otherwise I'll let you know by tomorrow, but I don't think so that you have any doubts, because I am not able to see any doubts and the viewers are very also less. So let us wait for 2 minutes. While on the other hand, speaking about this, if we do a quick review of what we did, we have seen both the ways of creating linked list in this case, where we have done linked list without classes also for the linked list class, and with the classes also for linked list class, where I have written all the functions, inside the linked list class, which makes our life much more easier to understand if we create it with the help. So the second scenario is far more fun and easy to use, where we just create a linked list class like this and we do the job directly. We don't have to worry about anything in this case. So directly create the class linked list and do the job. It is much more better actually, okay, rather than creating this kind of mess, okay, because here you have to use call by reference, call by values, call by so much things, right, pointers, double pointers, reference variables. So this way is far more easy. Create a linked list class, initialize the head directly inside that as an attribute of the class, and don't forget to miss the class tomorrow's C++ class, because it is going to be very important, highly important. Tomorrow I will be teaching you about the static functions, when we use a static keyword inside functions in object oriented programming. Tomorrow I will explain you about the constructors, what are constructors. I will be explaining about destructors, what are destructors, and we will go into depth of each and everything, guys. So tomorrow in C++ object oriented mastering class. And for today, I guess so this much is enough for today, and that is it, guys. Thank you so much for watching today's video, guys. I'll be seeing you in tomorrow's video, while I will be explaining you about the data structure. Again, I'll continue tomorrow's class, and I'll continue from this insert at tail. A quick homework if you want you can do, that is finish up the insert at tail. I have told you about the insert at head. I have told you about the traversal function. Now combine these two and try to insert at the tail, and if you put it in the comment section below, I'll be able to see in and I'll be able to get it into it. Well, that's all for today's class, guys, and thank you so much for watching today's class. I'll see you in tomorrow's class, and that's it. Thank you guys so much. All right.